Okay, welcome to the next lesson, or the continuation of this chapter. We're looking to finish up section 2 in chapter 12. We're going to learn how our targets are to write a rule for an arithmetic sequence given two terms and to find the sum of an arithmetic series. So we're going to one more way to write a rule for arithmetic sequences, and then we're going to do sums of series. Okay, so if we're just given two terms, this is bad news bears in an arithmetic sequence because this is the most work. It's like just given 2 points in a line, for a line, to write an equation of a line. What did we have to find when we were doing it that way? Well, we had to find the slope. Slope, so we had to find first before we could then find the y-intercept or any other points so that we can make an equation. It's similar here. If you look at this, I call this method, this is my preferred method. Method 1, we call this the slope method. Because we can count these values, a sub 6 equals 7 and a sub 22 equals 87 as xy coordinates. If you think of 6 as an input and 7 as a matching output, and 22 as an input and 87 as the matching output, we have xy coordinates. And if you remember way back when, this equation for a slope, which is the same as what part of our equation? Well, it's really the d, okay? And the equation for slope is x2 minus x1 over y2 minus y1. So what I do is I say, okay, here's x1, y1, here's x2, y2. We are going to use those values to find our slope. Oops, I totally reversed that. It should be y2 over, I think I said that. y2 minus y1 over x2. Rise over 1. Rise over run. The y's over the x's. So now we have that settled. 87 minus 7 over 22 minus 6. That is 80 over 16. 80 over 16. What does that divide out to be? Well, that's 5. So we have a slope of 5. So now we can go back to how we did it yesterday, and we can say, okay, let's take our d. Our d is 5, and we have at least one point that's on the line. I'll say a sub 6 equals 7. You could use the other one as well. It will work out the same. But I just say, okay, a sub n equals a sub 1 plus d times n minus 1. If a sub n, my output is 7, that's really my a sub n. My n value is 6. So 7 here, a sub 1, we don't know what that is. I now know that d, common difference, is 5, and I know that my 6, I'm going to plug in 6, I get out 7. So now I just simplify. 7 equals a sub 1 plus 5 times 5, which is 25. I subtract 25 from both sides. I see that my a sub 1 value is negative 18. So now I have a sub 1 equals negative 18. I know that my d is 5. I'm going to put those two things together, and I'm going to make an equation. A sub n equals a sub 1, negative 18, plus 5 times n minus 1. We, of course, know that distributing and combining like terms is necessary before we complete any problem. And negative 18 and negative 5, that makes a negative 23. I'm sorry, let's plus that and write minus 23. So a sub n equals 5n minus 23. I think that's the easiest way to do it. Oh. But there is another way. Now, of course, I would check this. How do you check this? Plug in these coordinates. Plug in 6, do you get out 7? Okay, plug in 22, do you get out 27? That might be a better way to check. Okay? Because when we plug in 22, is 5 times 22, does that equal 87? If it doesn't, then we made a mistake. 5 times 22, well, 5 times 22, that would be 110 minus 23. 110 minus 23, I believe, is 87. It checks. So that's kind of a way to do it and check to make sure you have the right answer. Now, another method you could use is system of equations. I'm just going to show it to you. I'm not expecting that too many people are going to want to use it, but you can. This is the way your book does it, so if you're looking at your book, this is the way they do it. System of equations, we have kind of similar idea. We know that our input 7, a sub 1 plus d times 6 minus 1, or with our input of 6, we get an output of 7, and with our output of 87, that's going to match up with our input of, what do we input to get 87? We inputted 22. So we simplify these equations a little bit. We get 7 equals a sub 1 plus 6 minus 1 is 5d, and 87 equals a sub 1 plus 21b. So now if we look at this, we have a system of equations. We can solve by the elimination method. We can get rid of a sub 1. So if I multiply the entire top equation by a negative 1, what I end up having here is a negative 7 equals negative a sub 1 minus 5d. And we don't have to do anything with the bottom equation because it's a positive 1 a sub 1. And when we combine these equations, I'm having flash from the past here, when we combine these equations, we'll get these things that cancel out. So now I'm going to add these two equations together. So that means I'm just going to add vertically. 87 and negative 87 is 80. The a sub 1 and negative a sub 1 cancel out. And I get 16d. I divide by 16. And I end up with d equaling 5. And guess what? That's what we got before, didn't we? We had the slope rise over run, 80 over 16. It's the same. It's going to come up with the same values. So now you would take that d value, you would combine it with one of your values, just like we did before, 5 times 6 minus 1, and it would be the same work as we had above. And I'm not going to go through the rest of it. But this is just a different way to get your d value using a system of equations, elimination. You could even use substitution if you really wanted to, solving for a sub 1 in one of your equations. Okay, sums of arithmetic series. The formula for the sum of arithmetic series is S sub n equals n times a sub 1 plus a sub n over 2. What do all these terms mean? And furthermore, do we need all of them? We'll talk about that in a minute here. N equals the number of terms. A sub 1 is the first term. We knew that already. A sub n is the last term. So you need the first term, the last term, and how many total terms there are going to be. So I'm going to show you how to use this formula, and then we're going to do one by using the graphing calculator. So for this one, it says find the sum. This is arithmetic because it's a linear rule. 9 plus 3i fits the mx plus b model. So we need to find a sub 1. A sub 1 would mean 9 plus 3 times 1, which is 9 plus 3, which is 12. So a sub 1 is 12. We need to find the last term. That's the 15th term in this case. So a sub 15 is 9 plus 3 times 15, which I'm not going to show it all that work. This time we get 54. So 54, and we know that our n value, there's 15. We start at 1, there's 15 terms, so n equals 15. So we can plug it into this formula. We get 15, 15 times 12 plus 54, all divided by 2. We plug that in our calculator and we get 495. Now, down here I can do the same formula, or I can use my graphing calculator. So let's refresh our memories on how to do sums. Okay, if we hit alpha and we hit window, Down here we have number 2, that's summation notation. I can do x instead of I, x equals 1. We're going to go all the way to 8. We're going all the way to 18. And then I write the rule, and instead of using I just have to use the x. So do I even need the formula for that? Not really. I can simply plug it in my calculator and do it that way. Okay? We're not going to do infinite sums, so here's a finite sum. So I think we successfully hit our targets today. We found a way to, most normally using slope method or system of equations to find a rule for an arithmetic sequence just giving 2 terms. And we also had a formula for finding sums and refresh our memory and calculating just for finding sums. Have your notes for tomorrow. We'll see you then.